What's up? So today we're playing on this 2005 Chevy Tahoe with a 4.8 liter engine in it. I went to get out of the parking lot earlier. Of course, battery was dead. And I got it started and it was running kind of crappy. So I started listening and wait, I hear spark. And I forgot we stole a spark plug wire off of this last year, and it was shooting a spark about yay long from it was a coil. These are the coil near plugs. They don't sit on top of the plugs, but there's one for each cylinder, and there's a short cable that goes down to the plug. And I'd stolen it off something because kid broke one on some car we had serviced, and so I stole it off of this one because they're brand new. And I forgot to replace it. Whoops! So I stole off another one. So we're good to go now. So this guy here has both a mass airflow sensor and, wait for it, oh, where did I end up? It also has a map sensor. So it has a couple of ways to keep track of things. Okay, so we're going to pay attention to both of them. Again, we're going to play the same game as on the other vehicle. We're going to drive it rich. We're going to drive it lean with a vacuum leak and with throwing extra fuel at it. Manifold absolute pressure sensor right there. Exactly. So, I'm going to pause us on this video here and get moved around for better recording purposes. Here we go. Why is this thing not? I don't know. This was the Grand Cherokee, so if you come back here, and we want an 05. Chevy, oh, no, sorry, forgot to go back and pick Chevy first. Sorry, my bad. My bad. Chevrolet. See the USA in your Chevrolet. One of the classic car commercials of all time back in the day. See the USA in your Chevrolet. According to VIN, the year 2004 does not match the year selected. I didn't say 2004, you jackass. I said 05. Isn't this an 05? Interesting. Maybe Mr. Groom made a boo-boo. Maybe I did not look. Maybe I was told it was an 05. Oh. No, it's an 04. Judas Priest. That's a little embarrassing now, isn't it, friend? Oh, my. Oh, my. There you go, stupid. What do you know about that? How about them apples, Ben? All right. So, there we have this. Nice. Whatever. Okay. Yes, clearly we want engine data. Yes, it has an automatic transmission. We'd like some data, thanks, if it's all the same to you. Let's do a little engine data. Now, notice this one's cool because it'll do misfire data, and we'll talk about some of these other data later on. Let's just do engine data right now and see what's what. Engine speed. Notice that the coolant temp and the intake air temp are almost identical. That should be true. That is 100%. That should be true. Okay? Now, why is that? Because the thing's cold. It's colder than all get out here today, but about 60 degrees. All right? I ran it in from the parking lot, so literally it's been running for maybe 20 seconds today. So, yeah, whatever. It's cold. Notice right now there is no grams of air coming in per second. None right now. That'll change in a few minutes. Okay? Come down here. There's the throttle position again. Now, here's our map sensor. Now, right now, it's measuring 29 inches of mercury. Okay? And that is basically our barometric pressure today. See that right there? Now, this is cool because this has both, right? And so you can watch them, and you should see what's happening between them as we go along. Right now, of course, it's in open loop. Duh. And then here is our HO2 sensors. You see that? There's our O2 sensors, heated O2 sensors, bank 1, sensor 1. That's upstream. Bank 2. Bank 1, sensor 2, that's downstream. Bank 2, sensor 1. Did I miss one? Bank 2, sensor 2. There they are. Okay? And then down here is our fuel trims. Now, of course, they're all at 0 because basically I have never run this thing, and the battery was dead when I brought it up here, so I had to charge it all day. So again, she should start right now, in theory. Yay! Yay! Got to be a better way to do this, Mr. Groom. All right, let's come back up here and check out, see what's what here, friends. Now again, notice that this one gives it to you in millivolts. See that? So 400 millivolts or 0.4 whatever. Okay. You come back up, of course, we're still in open loop. We expect to be that way for a little while. We'll keep an eye on it and see what happens here. Notice that our map sensor dropped considerably. Okay? Why is that? Because there's less pressure in the cylinder than there is in the intake manifold than there is outside currently. That is, there's more vacuum, which is negative pressure, in the manifold than there is outside of it. Okay? Let's keep an eye on this thing here for a sec. We'll wait till she goes closed loop. Keep an eye on her here. I want to see how long it takes. Notice we're getting a little switching here. This will always happen, but she's not in control yet. Marcy's not in control yet. All right, look at our sensor 2, our downstream. Okay, it's not nearly got hot enough yet. If it was hot enough, it would be running about 700 millivolts, give or take. Okay. Interesting. It's taking a long time to get into closed loop. Here's our MAF. Where did it go? I went bye-bye. There's our MAF sensor right there. Grams per second. Anybody notice the throttle position sensor is set to like 10%? You're like, well, what's going on with that? That's because this is a drive-by-wire system. So the way that it idles faster, the little stepper motor just opens up just a hair, lets some more air in. Notice as that more air, you're going to see this guy here change based on where the throttle position is. Again, we're still in open loop for some reason. I'm going to go step on the gas, see if I can speed this process up. Actually, I'll just pause you and we'll come back to it. Good night, nurse. We're finally back in closed loop. Took forever. Now, I want you to pay attention. Come down here to there's your upstream doing its thing. There's your downstream hanging out. It's a little high. It's not terrible. It's clearly lit off now. And then there's our other downstream. Again, they're running a little hotter probably than we would expect, but not terrible. Now come back up here and pay attention to the barometric pressure. That's outside pressure versus what's in the manifold. Now remember, the closer and closer and closer to zero it gets, right? We're talking about the difference between outside and inside. Okay? Right now, in essence, there's like 11. That's the difference between the inside and the outside. Okay? So I step on the gas, I open it up, whomp, there's very little difference between the two of them. So pay attention to that. Again, that's absolute pressure. Oop, I'm going to fall on my head. That change again. Remember, when we step on the gas, what's going on there is we obviously open the throttle plate up wide, and so there's very little difference between inside and outside when we do that. I'm going to pause you a second. I'm going to go ahead and I'm going to drive this guy rich, and we're going to cause a vacuum leak both on this guy again. Okay, so I am going to try to drive this guy rich. Okay. So we're going to keep an eye on our O2 sensors over here. I'm going to do it for a second, and then I'm going to shut them off. I'm going to shut the gas off, come back. I'm going to come over here and check on them myself. Unfortunately, the intake's on the other side of the vehicle. Okay, watch him. Look at him. Judas Priest. Holy crap, it's rich. Judas Priest. Look at it go. Now let's go look at our fuel trims. Cut the fuel, baby. Cut it. Now, as you can see, I've clearly shut it off. I shut it off about 15 seconds ago. It's just now catching up to us, okay? And we should start to see everything come back into play. Okay, those guys are going to bounce back around. Let's go look at what our O2s are doing. There's our O2s. There's Mr. Groom screwing with it. Judas Priest, watch it. And then I shut it off. And wham! I shut it down. Marcy goes, cut it. For God's sakes, cut the fuel. Or add fuel, rather. And so she said, so she tries to like, oh crap, we went lean all of a sudden. So she overdoes it and underdoes it and overdoes it. Now she's getting back into the scheme of things. As you know, ouch. Marcy's no different than the rest of us, okay? We make a change. Oh no, we did too much. Well, there's a shocker, right? There's a shocker. You did too much. Well, yeah, you overdid it. You didn't need that much, and you went too much. So we're not terribly shocked by that. Okay, we know what side the bread's buttered on here. Now I'm going to cause a vacuum leak. Keep an eye on it. Okay. Look at that sucker go lean. Judas Priest. Look at it go. Oh, geez, it almost freaking died. Add fuel. Add fuel, for God's sakes. Add fuel. Now she's back to normal. Okay, but it's going to take a second or two for it to start going, hey, what's up? Now pay attention to your short terms and your long terms. I had the battery off, okay? And the battery was dead, rather. And so it's going to have erased all the long term. So long term is really short term, kind of, initially when you first start off. Okay? So keep an eye on that. Marcy's doing a good job of trying to correct. Let's go see what the O2 sensors did. There it goes. Bam. Mr. Groom drove it just leaner than heck. Now again, over time, these guys, you will see a little bit of mirroring when we have extreme conditions. But as soon as we got back to normal, all right, as soon as we got back to normal, this is when I plugged it back in right there. It jumped back up. So then Marcy's like, whoa, that's too much. And she starts cutting the fuel. But notice that we are in good shape. For whatever reason, this Chevy is going to be running around 800 and some millivolts instead of 700. Now, by the way, that is not a hard and fast. It must always be 700, but it's going to be always be on the richer side on the downstream O2. Always. Okay? Because you're going to end up using what oxygen you had available to convert nitrous oxides, carbon monoxides, and fuel, hydrocarbons that is, to water, carbon dioxide, and nitrogen. Okay? And so, as a result, there's not going to be any free oxygen left. Hence, it's going to look rich. Now, don't get hung up that it's 800 and something. Again, if the car came in and had issues with drivability, that is, it was running crappy, or it had like a lean code, or a rich code for that matter, then yes, let's look at the fuel trims. For gosh sakes, yes, let's look at them. However, if it came in for a wiper motor or something ridiculous, or an evap code or something, what are you doing, bruh? Apparently it's fine. It is what it is. Okay? Now again, note when I pulled that baby off this time, did you notice how it sped up a lot more compared to the MAP sensor engine? I also wanted you to focus on the MAF. So let's go down here and look at MAF. Where's MAF at? There's MAF right there. Keep an eye on the MAF sensor. Okay? I'm going to give it another vacuum leak. So it's clearly getting more air. But I want you to see what happens to the MAF and what doesn't happen to MAF. Right? Interesting. Interesting. Look at that. Engine running like poop, right? And it did affect our MAP sensor. Interesting. Now that's a small leak right there. Still running poopy. That's a small leak. It's making somewhat of a difference. That big leak makes a huge difference in how much is coming in. Where are you at? Can't see you. Okay? Now, note, as soon as I plug it back in, things start going a little wonky and haywire. And again, why is that? Okay? Well, things start getting a little wonky and haywire on account of the fact that I plugged it back in and then she's corrected for it. Note here, by the way, your desired IAC, that's idle air control, changes based on what was going on. When I was messing with it, notice that the computer was trying to adjust the throttle position a little bit to try to keep the old girl running properly. Okay? Also note that the MAP sensor did change when I did that, which is not shocking. That happened on the other one as well. Okay? Let's come back and let's actually watch that MAP sensor on this one and see what it does. That's that top. Well, let's look at this one right here. Let's watch it again. So there's our map. Okay, now it's at 14 or whatever. All right. Why is that? Because it has more opening to the outside world right now. Okay. Shut her back down. There you go. Nice. Again, that's what we want to see. This is where I drove it lean, big time lean, right there. Now we're coming right here, rather. This is the upstream there, and that's an upstream right here, sensor 1. And now we're coming back to see if she overcorrected, and now she's going to start switching like she's supposed to do. Again, I want you to feel very confident when you see O2 sensor readings. I want you to feel confident what you see is reasonable or correct. And then I also want you to feel good about what these short-term and long-term fuel trims look like. Okay? Hey, what's going on over here? Well, clearly on the short term, we were adding for a while, and now we're dropping off. This one in particular, it didn't have as ginormous of a bump, but it did have a bump. When it went lean, it threw some fuel at it. Okay? It was able to correct. And then it's, again, running right around 0. That's where it should be. It should be running right around 0 all the time. In other words, if everything's tuned right, this thing shouldn't need to add or subtract any fuel. It should be running at the perfect amount that is prescribed from the factory. All right. I think I'm done yabbering.